Hello, in this video I'm going to be showing you how to solve exponential equations using logarithms. So an exponential equation is just an equation where your unknown is in the exponent or the power, and we're going to use logarithms to bring it down and then solve the equation. I'm going to be working through 3 different examples in this video, and I'll timestamp each of them below so you can skip through. They do get kind of progressively more tricky as the video goes on, and if this video is useful, please do go over to my channel where I have loads of other maths tutorials. Okay, so let's look at this first question where we're asked to solve 2 to the power of x plus 1 equals 5. And what makes this question difficult for us to solve is that the unknown is in the exponent, so it's not so straightforward to rearrange and make x the subject. And so the way we're going to solve this problem is by using logarithms. Now, you might initially be thinking, well, which base should we use? And to start off with, I'm going to use logarithms base 10. And then I'm going to show you another base that you may prefer to use. So let's answer it using logarithms base 10. So let's take logs of both sides. So we have log of 2 to the power of x plus 1 equals log of 5. I'm now going to use the power rule for my logarithms and bring the power down to the coefficient. So now we've got x plus 1 multiplied by log of 2 equals log 5. I'm then going to divide both sides by log 2, which is going to give me x plus 1 equals log 5 divided by log 2. And then finally, I'm going to subtract 1 from both sides, which is going to give me an answer of x equaling log 5 over log 2, subtract 1. And this would be an exact form of the answer. Now, if you're familiar with the change of base, then you could simplify this a bit more, but if you want to leave your answer exact, you could leave it like this. As a decimal, I'm just going to type this exactly as it is into my calculator and see what the answer is. So it's log 5 over log 2, subtract 1, and to 2 decimal places I get x is equal to 1.32. So I've found my solution, x. Now, if you want to check that this answer that you've just gotten is actually correct, you could look at the original equation, so this thing here, and I'm going to leave my answer exact in my calculator. I'm going to clear it, and I'm going to press 2 to the power of, and then answer, because that will be the exact answer from before, plus 1, and that gives me an answer of 5, which means that the answer I've just got must be correct. Okay. Now, earlier I said, well, which base do we choose to solve this equation? Well, I'm going to choose a different base this time, and I'm going to choose base 2. Okay, and you'll see why I've chosen that. So let's answer it again using logarithms base 2. So this is going to now be log base 2 of 2 to the x plus 1 equals log base 2 of 5. Again, I'm going to use my power rule to bring the x plus 1 down from the exponent, and I get x plus 1 multiplied by log base 2 of 2 equals log base 2 of 5. Now, if we take a look at this log base 2 of 2, well, this just says, what do I raise to the power of 2 to give me an answer of 2? Well, that equals 1. So this part of the equation just goes to 1, and so I get x plus 1 equals log base 2 of 5. Subtracting 1 from both sides gives me x is equal to log base 2 of 5, subtract 1. And again, if I type that into my calculator, it gives me an answer to 2 decimal places of x equaling 1.32. So we're solving the equation the same way. I suppose the benefit of choosing logarithms base 2 is you've got one less logarithm to deal with. So in this one, we had 2 logarithms. This one, you've just got 1. But you'll get the same answer, so it doesn't really matter how you choose to do it. Let's look at another question that's maybe a bit trickier. So here we're asked to solve 4 to the power of 5x plus 1 equals 5 to the power of 2x minus 1. Now, again, I could choose to use logarithms base 10, but for the sake of this, I'm going to choose to use logarithms base 4, okay, because that's going to simplify this a bit. So let's answer it. So let's take logarithms base 4 of both sides, and I get log base 4 of 4 to the power of 5x plus 1 equals log base 4 of 5 to the power of 2x minus 1. I'm then going to use my power rule on both sides to bring the exponent down to the front of my logarithm. So the right hand side is going to become 5x plus 1, all multiplied by log base 4 of 4. And the right hand side is going to become 2x minus 1, multiplied by log base 4 of 5. Now again, if we look at this logarithm here, we've got, well, 4 to the power of what gives me an answer of 4? Well, that's just 1, so this logarithm just goes to 1 like before, and I get 5x plus 1 equals 2x minus 1 multiplied by log base 4 of 5. Now, I need to get all of my x's now onto the same side of the equation, and the way I'm going to do this is by expanding the right-hand side. So I get 5x plus 1 equals 2x multiplied by log base 4 of 5 minus 1 multiplied by log base 4 of 5 gives us this. Now I'm going to put all of my x's onto the same side, and I'm going to do that by subtracting 5x from both sides of the equation, and at the same time I'm going to add log base 4 of 5 to both sides. Okay, so when I do that, this is going to turn into log base 4 of 5 plus 1, because remember I've added log base 4 of 5 to both sides, and that's going to equal 2x multiplied by log base 4 of 5 subtract 5x. Now to get x's on their own, I'm going to factorize out x from the right hand side of this equation, and so we get log base 4 of 5 plus 1 is equal to x multiplied by 2 log base 4 of 5 subtract 5. Okay, then I'm just going to divide both sides by everything in this bracket here, and so I get x is equal to log base 4 of 5 plus 1 divided by 2 multiplied by log base 4 of 5 subtract 5, and that is my answer for x. And again, if you wanted to, you could use your laws of logarithms to perhaps rewrite some of this and simplify it, but for this I'm going to leave it exact just like this. If you wanted it as a decimal, let's type this into our calculator and see what we get as an answer. And my calculator tells me, let's say to 3 decimal places it's negative 0.807. And we could do this little trick again to check if this answer is correct. So I could leave this in an exact form in my calculator, and we could look back at the equation we started with. And if I was to subtract 5 to the power of 2x minus 1 from both sides, then we get this equation here, 4 to the power of 5x plus 1 minus 5 to the power of 2x minus 1 equals 0. Okay, and what I'm going to do is type this into my calculator, and wherever there's an x, I'm going to use the answer button on my calculator. So I get 4 to the power of 5 times answer plus 1 minus 5 to the power of 2 times answer minus 1, and my calculator tells me that's 0, which means the answer we got must be correct. Now the final question, which is probably the trickiest one, there's many ways you could solve this question. So again, I'm going to try and get all of my x's onto the same side, and I think the first thing people are going to want to do is take logarithms of both sides, and you could solve this question that way, and in fact maybe you could try it and check at the end that your answer's the same as mine. I'm going to do it slightly differently, a way that you might not be used to seeing. What I'm going to do is I'm going to divide both sides by 9 to start off with, so this is going to turn into, well, 3 multiplied by 2 to the power of x over 9 equals 7 to the 2x plus 1. I'm then going to divide both sides by 2 to the power of x. Okay, so the left hand side is, well, 3 over 9, that's a third, and that's going to equal 7 to the power of 2x plus 1 over 2 to the power of x. Okay, I'm now going to rewrite the term on the right hand side, the 7 to the power of 2x plus 1, and I'll make it quite clear how I'm going to do that. So I'm going to use my laws of indices and rewrite 7 to the power of 2x plus 1 as 7 to the 2x multiplied by 7. Because using my laws of indices, well, the bases are the same, so we add the powers, okay? So let's do that. So I'm going to rewrite that 7 to the power of 2x plus 1 as 7 to the 2x multiplied by 7 to the power of 1. I'm then going to divide both sides by 7, so I get 1 over 21 equals 7 to the 2x over 2 to the x. And again, kind of using my laws of indices, I'm going to rewrite this on the right hand side, 7 to the 2x over 2 to the x, as 7 squared over 2 all to the power of x, because I just distribute the power across the numerator and the denominator. Okay, so hopefully you can see how that works, and you'll see why I'm doing this in a second. So now I've got 1 over 21 equals, well, 7 squared, that's 49 over 2 to the power of x. And from here I'm going to take logarithms of both sides. Again, the base doesn't matter too much, but using the little trick we used in example 2 where I chose log base 4, and the example I used in question 1 where I took logarithms base 2, I'm going to choose to do logarithms base 49 over 2, which might seem really strange, okay? But let's do that. So logarithm base 49 over 2 of 1 over 21 equals, well, log base 49 over 2 of 49 over 2 to the power of x. Let's then use our power rule to bring the x down to the front of the logarithm, and I get log base 49 over 2 of 1 over 21 equals x multiplied by log base 49 over 2 of 49 over 2. And again, like before, this goes to 1, and I get left with an answer of x of log base 49 over 2 of 1 over 21. And if I type that in my calculator, I get an answer for x of negative 0.952 to 3 decimal places. And we could do that little trick we used earlier where I'm going to subtract the right hand side of this equation from both sides, and I get 3 multiplied by 2 to the power of x, subtract 9 multiplied by 7 to the power 2x plus 1 equals 0, and leaving my answer exact in my calculator, I'm just going to type this in, and wherever there's an x, I'm going to use the answer button on my calculator, and hopefully when I type this in, my calculator is going to give me an answer of 0, which it does, which means the answer we got here must be correct. So hopefully this video was useful. If it was, do go over to my channel where I have loads of other maths tutorials, and thanks for watching.